Let's take a look at this problem, minimum number of flips to make binary grid palindromic. So in this problem we are given a 2D array of ones and zeros, and we have to make the entire 2D array palindromic such that all the rows and the columns both are palindromic. Also there is one more condition, that the number of ones in the final 2D array should be divisible by 4. Let's take a look at the examples that are given in the question. So the first example is this one. In order to make this 2D array palindromic, we have to make all the rows palindromic, which means that all these elements should be equal to the corresponding elements over here. Also, we have to make the columns palindromic, which means all these elements should be equal to all these elements correspondingly. Considering one more example, let's take this 2D array. Now, since the rows are palindromic, this element's mirror image, that is this one, should be equal, which is already there. Also the columns are palindromic, which means that this element should be equal to this one, and this element should be equal to this one. So in order to make this palindromic, we can either make these zeros to be equal to 1, or we can replace these ones with zeros. Doesn't matter, because in both the cases the final answer will be divisible by 4 for these 4 elements. Now talking about the second element, its mirror image on this vertical line will be itself, while its mirror image on this horizontal line will be this element. So this already satisfies the palindromic condition. Now let's talk about this element. Its mirror image on this horizontal line will be itself, while its mirror image on this vertical line will be this element. So we have two options over here. We can either make this 1 to be 0, or we can make this 0 to be 1 to satisfy the palindromic condition. But if we make this 1 to be 0, the divisibility by 4 will not be satisfied, because we have 1 and 2, these ones that will be left out in a pair. However, if we make this 0 to be 1, all these ones will make a group of 4, so this will be divisible by 4. In order to solve this problem, we will consider this smaller 2D array, because while considering this 2D array, all the remaining elements will also be considered. Now let's traverse element wise. When we are at this first element, its corresponding elements are this and this one. So the total count of ones in it is equal to 2, and we will add this 2 to our total count. If it was a 3, then we would have added a 1, that is 4 minus count. Now when we come to the middle element of a row or a column, we have to count two types of pairs. So the first one will be when we have a single one, or when we have a double one. If we consider this element, its corresponding element is a 1, so we add it to the pair of double 1, so our double 1 will become 1. While when we come to this element, its corresponding element is 0, so we add it to a single 1. Now to add it to our answer, we know that the single ones will all contribute to 1 each, because we can either make this 0 to be 1 or we can either make this 1 to be 0. So answer plus equal to single one. Now talking about the double ones, if we have double ones that are in pair, so we have four of one, then we do not need to consider over that. However, if there is some pair that is left out, that is if it's not divisible by 2, then we can take one single one and convert its 0 to be 1. Otherwise, if we do not have single one, then we can remove both the ones of that pair and add 2 to our answer. Let's try to code out the solution now. Let's consider n is equal to grid dot size minus 1, m is equal to grid 0 dot size minus 1. Now let's consider the final count to be 0. Let's return our count, and in between I need to take care of two variables as well. The first one will be int single one, which is equal to 0, and double one, which is also equal to 0. Now let's traverse in loops. So for int I is equal to 0, I is less than equal to n by 2 I plus plus, and for int j is equal to 0, j is less than equal to m by 2 j plus plus. So we are traversing the shorter 2D array, and inside of that let's take one variable, that is int temp count, which will count all the corresponding ones. But before that, let's count the corresponding indexes as well. So corresponding I index will be n minus I, and j index will be j minus m minus j. So temp count becomes grid ij plus grid ij plus grid ij plus grid ij. Now if I is equal to I and j is equal to j, which means that it's the middlemost element, like over here in the middle one. So we have counted the middle element 4 times, and we need to reduce that. So temp count divide equal to 4, and in our final count we will add the temp count. If that is not the case and we are at a middle element of some row or column, that is if I is equal to I or j is equal to j. So we are talking about the middle elements that we talked earlier in the approach. then in that case we have counted each element twice, so we will reduce the temp count by 2, and in here we need to check if temp count is equal to 2. That means we have two ones, so we will add double one plus plus, or if we have temp count equal to 1, then we will add single one plus plus. Now the normal case remains, and in that case we have to add something to the answer, that is count plus equal to minimum of the temp count, or 4 minus temp count. So we are doing this because if we have three ones, then it's better to add one as well instead of removing those three ones. Now outside of these for loops, what we will do is we will add to our count the single one count, which is the number of pairs with 1 1 and 1 0. And if we talk about this number of double pairs, and if those are not in pair, that is one pair is left out, that is if double 1 and 1, that is if it is odd, in that case what we will add to our count is, if we have at least one single one, then we can always add 1 instead of removing 1 from that pair. So we will add 0 in this case, because we have, for that case we have added a 1 1 to that pair instead of removing 1 from that pair, and for all other single ones we have removed all the ones, so they become 0 0. Otherwise, if we do not have a single one, we add 2, because we will have to remove both the ones that are present in the odd pair. Finally, we return our count, and let's try to run our solution now. And it should be accepted. Thanks for watching.